Greetings, everyone, and welcome. My name is Alex with the Climate Science Alliance, and today we're going to explore the Climate Kids Atmospheric Chemistry module and learn about small particles in our atmosphere called aerosols. We're going to investigate what these small particles are, where they come from, how they are impacting our world, and how scientists are working to better understand them. We will conclude with what it means to be a climate kid and how you can help protect the Earth and our atmosphere. If you have checked out our Climate Kids traveling trunk for this module, there are several associated hands-on science experiments and demonstrations to supplement this presentation, some of which can be found online at the Climate Kids Connects platform. There will be places to pause throughout today's presentation if you would like to participate. To begin, it's helpful to take a step back and understand where the aerosols are located. The air, of course. But what is the air? I encourage you to pause here and write in your notebook or maybe have a classroom discussion on what you already know about what makes up air. And how do we know air exists? Air is one of the most precious resources. We need it to maintain life on this planet, yet most of the time, we hardly even notice the air around us. Air is odorless, but it carries substances that we can smell. We feel air when it moves, and we can see the effects of air in the environment around us. When air moves, it has great power. For instance, it can push a sailboat in a harbor or create energy by rotating a windmill. When air is compressed, it maintains great strength, like when it fills your tires to drive your car on the road. Air is not a single entity, but rather a mixture of several different gases, such as oxygen, nitrogen, carbon dioxide, and many more. In addition to the gases that comprise the air, our atmosphere also contains very small liquid droplets and solid particles known as particulate matter. These particles play an important role in our everyday lives, but are just so small that when you look at the air around you, you usually can't see them with your bare eyes. In areas that are highly polluted with particulate matter, however, the difference is clear. For example, when you look at this photo of downtown Los Angeles, what do you notice? If you said it looks like there's a lot of dust in the air, you are correct. That dust is particulate matter. These very small liquid droplets and solid particles are lightweight, so they can float in the air for a long time without falling to the ground. In other words, the particles are suspended. When particulate matter is suspended in a gas, it is called an aerosol. When you hear the word aerosol, you might think of a can of hairspray or spray paint. When you release the hairspray or spray paint out of its can, it releases a mist of small liquid droplets called an aerosol spray. However, when scientists think of aerosols, their definition of an aerosol is slightly different. The particulate matter in our atmosphere can also be referred to as an aerosol because it is suspended within the gas in the air. Essentially, aerosols are incredibly small particles suspended in air. So we know that there are small particles suspended in the air called aerosols, but where did these aerosols come from? How did they get into the atmosphere? Feel free to pause here and write your answers in your notebook. Aerosol particles come from a variety of sources. Some are naturally occurring, while others are caused by human activities. One of the natural sources of particulate matter is mineral dust in the desert. When air is heated, it becomes less dense, which causes the air to rise up into the atmosphere. This process is known as convection and generates wind. The wind can carry particulate matter from the surface high up into the atmosphere, where it can be transported across large distances, even between continents. Another natural source of particulate matter is sea spray from the ocean. Think about walking along the beach. Does the crisp ocean breeze feel different from when you are further inland? When you are near the ocean, you are probably feeling the sea spray, small droplets of water and other particles that are suspended in the air. The ocean water contains salt and other organic compounds that are released by the algae, bacteria, and other life forms that live in the ocean. When waves break, droplets of seawater containing these salts and organic matter are entrained in the atmosphere. The water in these small droplets can evaporate, which leaves a small particle made up of the sea salt and organic compounds. There are also human sources of aerosol particles, and they include smoke from fires, vehicle exhaust, and factories. When hydrocarbon fuels, such as the gasoline in our cars, are burned, what happens? Well, on a cold day, you may see smoke coming out of the exhaust pipe in your car, and maybe even some drops of water. When fuel is burned, it undergoes combustion. Combustion is a chemical reaction where the fuel reacts with oxygen, or O2, in the air to break down into smaller compounds. The main products of this combustion are carbon dioxide and water. However, these fuels can also react through incomplete combustion, which forms carbon monoxide instead of carbon dioxide. When incomplete combustion occurs, particle byproducts called soot are often formed. Soot contains the leftover carbon that wasn't converted to gaseous carbon monoxide. What are some other human sources of aerosols that students can think of? I encourage you to add these to your notebook. To better understand our discussion of aerosols and their sources, we have two hands-on activities in our traveling trunk. For our first activity, we'll explore the role of aerosols in our atmosphere. Aerosols provide substrates, or surfaces, upon which water molecules can condense, grow into drops, and eventually fall as rain. If you have the traveling trunk, the cloud in a bottle demonstration can guide your students through exploring and testing this concept in different scenarios. The second activity focuses on one of the primary sources of human-derived aerosols in the atmosphere, the incomplete combustion of gasoline in car engines, like what we talked about earlier. The result of this incomplete combustion is what we know as smog, which is typically visible as brown haze over most large cities, and soot, the aerosol byproduct of leftover carbon that is not converted to gaseous carbon monoxide. How do our aerosols impact the planet and you? Take a few moments to write your answer in your notebook, thinking about different ways that you might be influenced by aerosols. These tiny aerosol particles are important to our community as well as our planet. They influence human health and the Earth's climate in both direct and indirect ways. Let's start by exploring the role aerosols play with the Earth's climate. The additional reflection caused by pollution aerosols is expected to have an effect on the climate comparable in magnitude to that of increasing concentrations of atmospheric gases, as they are able to change the Earth's energy balance. Aerosols can control how much energy from the sun reaches the planet's surface by changing the amount that is absorbed in the atmosphere and the amount that is scattered back out into space. The effect of aerosols, however, will be opposite to the effect of the increasing atmospheric greenhouse gases, cooling instead of warming the atmosphere. The warming effect of the greenhouse gases is expected to take place everywhere, but the cooling effect of the pollution aerosols is somewhat regionally dependent and closer to industrial areas. Since the Industrial Revolution, humans have pumped more and more aerosols into the air, and this in turn has counteracted global warming to a significant degree. So you might be wondering, so are aerosols a good thing? The answer is no. Though aerosols have limited warming, they also impact other significant portions of the Earth's climate system, such as rainfall, reducing rain in areas like India and China, where it is desperately needed for food production. In addition, aerosols also alter wind and weather patterns and atmospheric circulation. Atmospheric systems are complex, and the addition of human-driven aerosols inserts many unknowns. To recap, the climate of our planet is influenced by a number of factors, including the sun and the gases in our atmosphere. Aerosols also affect climate. Aerosol particles have a complicated role in our climate and have both direct and indirect effects. As a direct effect, aerosols can scatter sunlight directly back into space, and this can result in a cooling of the Earth. How does this work? Well, the light radiation from the sun travels to the Earth, where it provides the planet with a source of heat that drives our planet's climate. However, not all of the light radiation from the sun reaches the Earth's surface. This is because aerosol particles, and the clouds that they help form, scatter about 25% of the sun's radiation back into space. Because less of the sun's radiation reaches the ground, this results in a cooling effect. Conversely, aerosols can also absorb energy from the sunlight and warm layers of air in the atmosphere. As an indirect effect, aerosols also affect cloud formation. Without aerosols and water vapor, rain clouds will not form. We saw this demonstrated in the cloud in a bottle activity. As water molecules condense on aerosol particles and form tiny droplets, they join together and form larger and larger drops until they are heavy enough to fall as rain. The concentration of aerosol particles affects the size of raindrops. Though the overall amount of water is the same, the size of raindrops and duration of clouds varies. When there are a few particles in the air, the water vapor is condensed to give larger droplets, which result in clouds that are less white and more likely to cause rain. When there are many particles in the air, the water vapor is spread across all of the droplets, which results in whiter clouds that are less likely to cause rain. In the following activity, what makes a greenhouse gas, will help students understand and explore the greenhouse gases' effect in our atmosphere. As we will recall, aerosols can control how much energy from the sun reaches the planet's surface by changing the amount that is absorbed in the atmosphere and the amount that is scattered back out into space. The effect of aerosols, however, will be opposite to the effect of the increasing atmospheric greenhouse gases, cooling instead of warming the atmosphere. The warming effect of the greenhouse gases is expected to take place everywhere, but the cooling effect of the pollution aerosols is somewhat regionally dependent and closer to industrial areas. Feel free to pause here and have your students participate in what makes a greenhouse gas. Energy from the sun can be reflected back to space or absorbed by the Earth. Albedo is the amount of light reflected from a surface compared to the amount of light that strikes the surface. Light that is not reflected is absorbed by a surface and can be observed as heat. On a global scale, the Earth's temperature is affected by how its surface reflects and absorbs solar energy. On average, 30% of the sunlight reaching the Earth's atmosphere is reflected, mostly by clouds. Clouds have a significant impact on the temperature of the Earth and keep Earth cooler by reflecting the sun's energy back into space. Because aerosols impact the formation of clouds and subsequent reflectivity of heat, understanding the concept of surface albedo is important when considering how aerosols work to influence the Earth's energy budget. To explore this concept more, feel free to use the hands-on activity in the traveling trunk to explore surface albedo and global change. Now we have fully explored the impacts of aerosols on our climate. We can turn our attention to the other large impact of aerosols, and that is on public health. Aerosol particles can contribute to a variety of human health problems. Particulate matter affects the health of more people than any other pollutant worldwide. According to estimates from the World Health Organization, particle pollution contributes to approximately 7 million premature deaths each year, making it one of the leading causes of worldwide mortality. The health effects of the particles are directly related to their size. Particles greater than 100 microns are generally too large to be inhaled. Particles between 10 and 100 microns can be inhaled, but are usually stopped by our body's filters, the mucous membranes in our respiratory system. The term inhalable particles typically refers to particles less than 10 microns in size that can make it past the body's defenses and deep into the lungs. These particles pose the most health risk. Inhalable coarse particles are particles between 2.5 and 10 microns in diameter and are typically found near highways and factories. Fine particles have a diameter less than 2.5 microns and are typically found in smoke and smog. These particles make it deeper into the lungs. A significant portion of these fine particles are deposited into the trachea, bronchioles, and alveoli. Scientific studies have linked particle pollution to a number of health problems, including aggravated asthma, decreased lung function, irritation of airways, coughing, difficulty breathing, premature death in people with heart and lung disease, and irregular heartbeat. Because of the negative health impacts of aerosol particles, the United States Environmental Protection Agency has set national ambient air quality standards to limit the levels of air pollutants such as fine and coarse particles in ambient air. The EPA uses a number between 0 to 500, known as the Air Quality Index, or AQI, to report the daily air quality. Each AQI number is associated with a certain level of health risk. The AQI is based on the 5 major air pollutants regulated by the Clean Air Act: ozone, or O3, particle pollution, size PM2.5 and PM10, carbon monoxide, or CO, sulfur dioxide, SO2, and nitrogen dioxide, NO2. We will explore the aerosol impacts to public health and the air quality index in some of our hands-on activities. Aerosols and other air pollutants affect both humans and the environment. In the following activities located in our traveling trunk, you can test the air quality around a school, learn about the air quality index, and talk about actions you can take to better take care of our air. Living in the modern world, our society continues to face many global issues, from human disease and hunger to pollution and climate change. Science plays a critical role in helping us learn about how these issues affect our world and how we might go about fixing them. Every day, scientists work to better understand the issues that face us. However, these problems are large, complex, and complicated, meaning we have to work together to figure them out. No one scientist can solve these issues alone, but together, teams of scientists can work to build knowledge that will be needed to work through these challenges. The team of researchers at the NSF Center for Aerosol Impacts on Chemistry of the Environment, or CASE, are working to understand how particles in our atmosphere impact our environment and climate change. Led by Professor Kimberly Prather, UC San Diego Distinguished Chair in Atmospheric Chemistry, the center's goal is to understand critical details regarding the chemistry of aerosols. CASE has assembled an interdisciplinary team of scientists to accomplish this task, looking at atmospheric, physical, biochemistry, analytical, and organic chemists, along with oceanographers and marine biologists. They all work together to better understand aerosols and the impact they are having on our planet. CASE tackles the grand challenge of understanding how the chemical complexity of atmospheric aerosol particles impacts our atmosphere and climate. One important type of aerosol that CASE researchers study is sea spray aerosols. CASE has developed a strategy that brings the complexity of the ocean-atmosphere interaction into the lab, allowing for detailed fundamental studies of aerosol reactions, which is one of the largest gaps in our current understanding of climate change. Like CASE researchers, climate kids, that's you, are also scientists. Climate kids use science, art, and storytelling to help understand and protect the Earth. As a scientist, climate kids have 3 main jobs. The first, figuring out the problem of climate change. The second, finding innovative solutions. And the third, and most important, telling the story. As climate kids and scientists, there are many things you can do to protect our environment, our community, and our Earth from the impacts of atmospheric aerosols, such as the ones that you see here. Things such as saving water, recycling, eating your veggies, using less electricity. There's so many to choose from. What do you want to commit to doing to help the Earth and lower your impact? I encourage you to pause here and write what your climate commitment will be in your journal. Thanks so much for joining me for today's lesson. To find out more, please visit us at the Climate Science Alliance or Climate Kids at www.climatesciencealliance.org or www.climatekids.org. Have a great day.